This video is going to be going through the solutions to the equations test. The first part in multiple choice, question 1, says which of the following is not an equation. The important part is not. So we know that anything with an equal sign in is going to be an equation, so it can't be these three, which means that D has to be the correct answer. It is not an equation. Number 2, the value of the missing number that would make this equation true is. So we could do an actual proper solution, but it might be quicker just to do a little bit of trial and error. So we're trying to get to 32 from 18. So 18 plus 4, of course, will not be 32. 18 plus 6 cannot be 32. 18 plus 14 would be 32. So that would be the answer C. The correct equation for the statement number 3, where the sum of P and 5 is 12. So let's think about that equation for a minute. P and the sum being plus 5 equals 12. So that is what our equation is. So we're looking for one that matches that. And of course, that is C here. Number 4, the sum of 5 and x is 9. So again, it doesn't hurt to write it out. The sum, so we know it's an addition of 5 and x equals 9. So that's what we're looking for. So let's find which one it is. X equals 5 plus 9 is A. So again, it doesn't matter which way we have that round. No, that's not it. 5 plus x equals 9. There it is, B. The correct equation for the statement of 8 subtracted from k is equal to 24. So we've got k, we're subtracting from that 8, and it's going to be equal to 24. So that is the equation that we're looking for. So here we go, 8 minus k, no. K minus 8 equals 24. It's obviously B. Let's move on to the second page. The solution to 4m equals 20. So 4m equals 20. Again, we can do the proper math, but let's just quickly do this in our head. Think about our 4 times table. What multiplied by 4 is going to be our m to get 20? Of course, we know straight away that m has to be equal to 5. 4 times 5, of course, being 20. Equation A and equation B are equivalent. So equation A, we have 3x plus 2 equals 8. And equation B, we have 3x plus 10 equals 16. So it's saying to us here, out of these A, B, C, D's down at the bottom here, which of these statements is true to make sure that the statement A up the top and B up the top here are equivalent. So basically what has happened to A and B to make them equivalent. So let's have a look at it. 3x has not changed in either part. All right. Here we have a 2 and here we have a 10. What's different between those two? There's 8 different between them. Let's look at our answer. We've got an 8 and a 16. What's different between them? 8. So we can clearly see here that we have added 8 to the value of B, so it became plus 10, so that both of those are the same. So we're looking for something that equates to that. So both sides of equation A have been multiplied by 2. Certainly not. Both sides of equation A have had 8 added to it to become B. So it has the equation A, both sides have had 8 added. Yes, because we've had plus 8 added here to make that into the 10 that we see here. We've had plus 8 added here to make that into the 16 that we had showing in B. So the correct answer is B, that both sides of equation A have had 8 added to give the equation that we have in B. That one was just a little bit trickier, possibly for the wording. Question 8. When solving the equation 3a minus 5 equals 19, which step should be performed first? So remember here we are doing this in the reverse order, to what we would normally do to solve it. So normally we would solve by doing 3a and then taking 5 away from that answer. But to undo, we do it in reverse. So we'd be trying to undo this minus 5 first. And to do that, we do the opposite, which would be to plus 5 here and plus 5 on that side. So we are looking to do this, okay, which is add 5 to both sides. Okay, question 9. The result of adding 5 to both sides of the equation is, so let's have a look at it. We're going to add 5. So this would be, I'll write it out, 2m plus 5 sorry, try that again, apologies. 2m plus 3, we've got here, plus another 5, okay, that's adding 5, is equal to 12 plus another 5. So we look at that, that's 2m, that becomes plus 8, is equal to 12 plus 5 is 17. So which of those equations, of course, matches? And it is the first one here, which is A. And the last multiple choice question, which value of x makes the equation 3x plus 1 equals 16? So again, we could do a proper solution where we minus 1 from both sides and divide by 3, but it's quick enough that we can do this multiple choice in our head. So of course, we're going to take 1 away, which makes this to be 15 on the equal side. And then think about a 3 times table. 3 times what will give us 15? Of course, that is going to be the value 5. So I don't know why on this screen it's gone down to the next page, but of course the answer should be D, x equals 5. So 3 times 5 would be 15, plus 1 would give the 16 that we're expecting there. Let's move on to part B, short answer. For these first two again, we don't necessarily have to show all our working out because it's just asking a true or false. So for each of the following equations, circle whether it is true or false. So 12 minus 4 is equal to 32 divided by 4. So of course 12 minus 4 is 8. All right, and 32 divided by 4 is also 8. So of course that is true. 3 times 5 is 15. 7 plus 9 is 16. So of course 15 and 16 are not true, or not equal, sorry. So that's a false. For number 2, if k is 6, are the following equations true or false again? So we're replacing the k with a 6, so it's going to be 6 times 8 is 54, which of course is false. And 9 plus k, which is actually 9 plus 6, so this left-hand side is going to be 15. And 2k plus 3, so that's going to be 2 times 6 is 12, plus 3 is 15. So of course both sides of the equation are true, so the answer there is true. Moving on to question 3. Solve each of the following equations. So at this point now I do expect to see the full working out, and again preferably showing the different colour to make it clear when you're showing out your working. Again, this pretty much happens from here on out. So we should be seeing a plus 6 equals 14. We need to undo the plus 6. So we're going to have a plus 6. Then we're going to have minus 6 on there, being equal to 14 minus 6. Of course, that means these now cancel out. So we end up with a being equal to 14 minus 6, of course, is 8. Okay, so there's our first solution. B minus 3 equals 5. So we're going to have b minus 3. Undoing a minus is plus 3, equal to 5, also plus 3 on that side, which of course then means we've got the b left over being equal to 8 as well. For C, 4c equals 28. Remember, we are undoing the multiplication by 4, so we do that as a division, and we should be showing that in the fractional form. So it's divided by 4 on both sides. Okay, so they cancel out, of course, so we end up with C being equal to 7. And for D, just move it up a little bit here, we have 9D equals 27. So again, this is just undoing a multiplication. So we have 9D equals 27. We're going to divide by 9 on both sides. Okay, so they cancel out, so we end up with D being equal to 3. 27 divided by 9, of course, being 3. Now, f over 5, or f divided by 5, equals 10. I know a number of students had some trouble with this one, but again, we're trying to undo this divide by 5 on the bottom, so it's just a multiply now. So we have, oops, let's get my pen back, sorry. F divided by 5 now multiplied by 5, because we're undoing this division on the bottom, is going to be equal to 10 multiplied by 5, doing the same on both sides. So those cancel each other out, so we end up with f being equal to 10 times 5, of course, is 50. And that was on the help sheet that I'd provided to you, and almost an exact copy of that one there. Let's move on to question 4, solving each of the following equations. we can already see that these are going to be two-step because we have a multiplication and also an addition of a constant number. So we know these are going to be that little bit longer. So again, 2a plus 9 equals 17. We're going to undo the plus 9 first. So 2a plus 9, and then we're going to be minus 9 to undo that, is going to be equal to 17 minus 9. So of course those plus and minus 9s cancel each other out. So we end up with 2a being equal to 17 minus 9, of course, is 8. Now we're going to undo the 2a. So we're going to have 2a divided by 2 to cancel out that multiplication, is equal to 8 also divided by 2, the same on both sides. And of course, that becomes a is equal to 8 divided by 2 is 4. Now, I did ask in class that you always do the proof, and I'm going to do that here as an example. But in this test, I also said to you in class that I won't expect you to do the proof just for the sake of time. But it's always a good idea, if you've got the time to do it, to make sure you haven't made a mistake. So again, the proof would simply be to say that if a does in fact equal 4 that we've worked out, we substitute that back into our original equation, which was 2a plus 9 equals 17. So substituting where we had a, would have 2 times 4 plus 9 equals 17. Do our multiplication first. So 2 times 4 is 8 plus 9 equals 17. Of course, 8 and 9 is 17, equal to 17. Both sides of the equation are equal, so that proves that we're correct. So again, this is a great idea to always do, certainly in your own working out. In this particular test, for time's sake, I told you didn't have to. If you did it, great. It would make sure that you've got it right. If you did, of course, I didn't give you any bonus points, unfortunately. And if you didn't do it, of course, you didn't lose any points. But always good to remember to try and do that if we can. Let's move on to B then. So 4b minus 12, we've got to undo that minus by doing an addition, is going to be equal to 24, also addition of 12. Then, of course, they cancel out. So we have 4b being equal to 24 and 12 is 36. And then to undo the 4 times b, we have to divide. So we're going to have 4b and 36, dividing both sides by 4. Okay, so we end up with b being equal to, what's 36 divided by 4? 12. No, what am I saying? My brain's deserted me for a second, so I'm going to use my calculator. 9, of course, I should know that. And that's actually raises a very good point. A lot of people, in looking through these tests, made really what are silly mistakes. And again, because you were allowed to have a calculator in this test, there really is no excuse for silly mistakes in your addition, your multiplication, and so forth. You are not expected to have done this all in your head. So just like I did, everyone makes mistakes, and that was a legitimate mistake. I just honestly blanked as to what 36 divided by 4 was, but I've got my calculator and I made sure I used it so that I don't make that silly mistake. Okay, moving on. D divided by 3 minus 2 equals 6. So, of course, we're going to do D divided by 3 minus 2. We have to undo the minus 2, so it's plus 2 is going to be equal to 6, also plus 2, which means we end up with D divided by 3 being equal to 8. We have to undo that divided by 3, so we're going to have D divided by 3 multiplied by 3 being equal to 8 also multiplied by 3, which then gives us the D, because of course they cancelled out, being 8 times 3. And again, I don't know why, but my brain's just really struggling. I'm actually recording this quite late at night, so it's probably not the best time to do this. Of course, 8 times 3 is 24. I'm sure you were all sitting there going, Mr. Tomic, you know this. But yeah, again, use your calculator. Don't make a silly mistake. So yeah, D is equal to 24. Let's move on. Extended response. Now, again, a number of people made what I consider very silly mistakes here, partly by not even reading the question carefully. So let's have a look at it. Jim, the electrician, charges $60 per hour plus a $40 flat rate call-out fee. Now, we literally had these examples in our revision. So if you did all your revision and did it properly, there should be no reason for you to struggle with this type of question, honestly. So please, again, make sure you're doing all your revision and checking your work leading up to a test. The first part A says define a variable for the number of hours Jim worked. Some people wrote some really bizarre things here. Put equations, put, just numbers. It's a variable. So something like H. Oops, need a pen. H, right? H is going to represent the number of hours. Or it really could be anything, but I'm going to go with H, all right? Then part B says to write the equation to show how the total cost C of the job is calculated. Now, I know some people got C and started freaking out about what does C mean. C is just going to represent the total amount he gets paid or the total cost for that job. Let's go back. He's $60 per hour. If we're saying the hours, the number of hours is H from in part A, then it's going to be 60H. $60 times how many hours he works, plus the flat rate of 40, so plus $40. So for every hour he works, all right, we're going to have 1 times 60 for every hour plus a total dollars of 40 extra. So this is our equation. And the only difference I should have seen from any of yours would be depending on what you chose to define the variable. So if you decided to call the variable Z for some reason, then yours would have been 60Z plus 40. All right, it wouldn't have changed the structure. All that would have changed is what variable you had there, and of course it should have matched this variable that you put up the top there. If you didn't match the variables, then I would also be wondering what you're up to. Now, if Jim spent 3 hours on a job, how much will Jim charge the client? So this is actually just substitution. We've written our equation up the top. It is 60H plus 40 is equal to the total amount that he will charge. We've been told that it is 3 hours, so we substitute 3 in for H. So if H equals 3, that's what we're basically saying. We now have 60 times 3 plus 40 is going to be equal to how much we charge. So 60 times 3, of course, is 180, plus 40 is whatever we're charging. 180 plus 40, of course, is 220, all right? So the total amount we're charging is $220. Now, it is a worded question, so really I would have liked to see a worded answer. So we should have written something like, Jim will charge $220 for 3 hours work. So we should have seen something like that. Now, part D says on a different job, on another job, the cost will be $460 in total. What would be the number of hours Jim worked on this job? And it even gives you a hint that you need to substitute the value into your equation from part B, then algebraically solve. So in part C, we were doing just a simple substitution that we did in the algebra unit. In part D, we're really doing what we've been focused on in the equation unit, which is solving for an unknown. So here we know what the total is. We know that 60H, right, plus 40 is going to be equal to 460. Here's our equation on the left-hand side that we've worked out from part B, and we now have the total amount 460. So now we're just reversing everything and solving this equation. So we start by undoing the plus 40. So we have 60H plus 40, undo the plus to be minus 40, is equal to 460, also minus 40. And again, I know lots of people made silly calculation mistakes here. So 60H is now going to be equal to 420. We're undoing a 60 times, so that's going to be 60H equals 420, with both sides being divided by 60 to cancel out, all right, that multiplication. So these end up cancelling out. So we end up with H being equal to, and again, I'm going to use my calculator so I don't make a silly mistake, 420 divided by 60, which is 7. So the hours is 7. And again, a worded question should have a worded answer. So Jim will have worked 7 hours to earn or charge, whichever way you want to put it. What was it? $460. Hopefully you space your work out a bit better than I have here, but there's my final answer. All right, last part here. In Australian rules football, the goal is worth 6 points and a behind is worth 1 point. This can be represented as S equals 6G plus B, where S is the total score that we get, G is the number of goals we get, and that's multiplied by 6 because there's 6 points for every goal, and B are the behinds. Just B by itself because they're only worth 1 point. So what is the score for a team that has scored 9 goals and 8 behinds? Again, this is just a substitution, all right? We're going to have 9 goals, so it's going to be 6 times 9, 9 being the G value, plus, 8 behinds, right? We work that out. 6 times 9 is 54, plus 8, and again, just for space, I'm going to come across here. So 54 and 8, of course, is 62. So 62 points, all right? And again, try to write a word answer if you can. So 62 points with, 9 goals and 8 behinds. So something like that would be ideal. So that was just substitution again. Part B, how many behinds or B value did a team make if they scored 4 goals, which is our G value, and had a total score of 37? So again, think about our formula. S equals 6 times G plus B. We've got the S, so we know the S is 37, the total number of points they scored is going to be equal to something times G. Oh, so they got 4G, so it's going to be 6 times G, G being 4 in this case, so we'll do that, okay? Plus B. We don't know what B is equal to, okay? So let's see what we can work out. Let's just fix up what we know. So it's actually 37. 6 times 4, of course, is 24 plus B. We can rewrite that the way that we're a bit more familiar with because it's just an equals. So 24 plus B is equal to 37. And if we look at that, we can now clearly see this is just an algebraic equation that we can solve. All right. So remember this 24 plus B can also be written as B plus 24 because it's just an addition is equal to 37 if that helps you see what to do. So now we've got B plus 24. We have to undo the plus 24. So we're going to say B plus 24 minus 24 is equal to 37 minus 24. Okay. Of course, they cancel out, so we end up, and again, sorry for the space, we end up with B being equal to 37 minus 24, of course. Again, I'll use my calculator just to be sure. My brain is starting to go to sleep right now. 13, so B is equal to 13. All right, so how many behinds did they get? They got 13 behinds and 4 goals to get a total score of 37. Again, let's quickly double check that. I don't have room to show it on here, but I'm doing that in my calculator. So it's going to be 6 times how many goals, which is 4, gives me 24, plus the 13 points for B, and that does equal the 37. So that is correct. So they scored 13 behinds. All right, something as simple as that for the final answer. And then part C says, how many goals did a team make if they scored 10 behinds and had a total of 52 points? So again, this is just another one where we have to solve it. So we start off with the original equation, S equals 6 times G plus B. They've given us our S, which is 52 points in total, is going to be equal to, we don't know how many goals they've done, so it's 6 times G still, plus they've told us how many behinds. So we know what our B is, which is 10. Let's just swap that around so we can see 6G plus 10 is equal to 52. And we're only doing that because it looks a bit more familiar to us the way we've got it set up. And now we've got something that we can solve. We're solving it for G, so it's going to be 6G plus 10, undo the plus with a minus 10, is going to be equal to 52, also minus 10 on both sides. which means we end up with 6G being equal to 42, okay, because of course they cancelled out. We then say we have to undo this multiplied by 6. Sorry, my screen's jumping around there. We have 6, sorry, struggling here. 6G equals 42. We're going to have to divide both sides by 6 to undo that multiplied there. So, of course, they cancel out. So we end up with G being equal to 7. I'm just double checking that as well. As I've told many times, my brain is shutting down. Yes, 7. Okay, so G is equal to 7. I'm going to do one more proof here just because I can. We talked about that before. So if G does in fact equal 7, all right, we've got 52 plus 6G, which you were saying 7, plus 10. So not plus, that's equal there, sorry. So 52 equals 6 times 7 is 42, plus 10. 52 is equal to 42 and 10 is 52. Both sides of the equation are correct and equal, so that's fine. Worded question, so we should write a worded answer. So the team scored, what did we say, 7 goals. There's my final answer. And that is the end of the test. So there's a bit to do in the whole test, but again, they were all very, very similar, if not the same structure to the revision that you were given, the 2 different sets of revision. So again, if you had done your revision, as we've talked about in the past, you should have been able to do these sorts of questions. If you don't learn anything else, if you don't take anything else from this, yet again, it is the importance of doing all your practice work and especially your revision so that you can do the tests. We don't write tests to trick you. We write tests that will test your knowledge. But again, we always write them around the sorts of questions that you have seen. So please take that on board as we finish out this year. Oh, I don't know why I changed font there, but anyway, so take that on board, and please, for your future endeavours in year 8 and onwards, make sure you do your work, make sure you're checking your work, but also make sure you're really focusing on the revision work as well. Thank you if you have watched through this, and if you've got any questions about your test, I'm still happy for you to email me, even though the term is probably finished. In fact, the year is finished. And I will do my best to contact you if appropriate. Okay, that's it. Thank you, everybody.